Hello and good day everyone. We are the second group and we are about to discuss simple vapor compression refrigeration systems. So to start with, I am Ruel Tagadiand and I am assigned to discuss the introduction. So vapor compression refrigeration system. Refrigeration is a branch of science which deals with the process of reducing and maintaining the temperature of a space or material below the temperature of the surroundings. The best example of this is refrigerator that operates the process of refrigeration which reduce or maintain the temperature of a space below the temperature of the surroundings. Refrigerant is the working substance in a refrigeration system. Therefore, refrigerant is the main reason why certain space in the refrigeration system maintain the desired temperature below to the atmospheric temperature. The very common refrigerant in the refrigeration system is ammonia. And by the way, refrigeration system operates reverse Carnot cycle compared to heat engine that operates Carnot cycle. Under simple vapor compression refrigeration system, we have four components, which are compressor, condenser, expansion valve, and evaporator. Compressor, consider reversed and adiabatic compression from saturated vapor to the condenser, or other called it isentropic process or constant entropy. That's 1 to 2 process. In the compression, there is also work and theoretical compression power that will explain further together with my teammates. Second, the condenser. Considered isobaric heat rejection or constant pressure. The superheating and condensation, that's 2 to 3 process. By the way, the inlet of the condenser is considered saturated vapor and the outlet is considered saturated liquid. Third, expansion valve. Considered a reversible expansion at constant enthalpy or isentalpic from the saturated liquid to the evaporator pressure. That's 3 to 4 process. Lastly, the evaporator. Considered reversible addition of heat at constant pressure in evaporation to the saturated vapor.
So hello everyone, so my name is Michelle and so I'm going to discuss the analysis of the vapor compression. So what do we mean by compressor? Okay, what's the rule? What's the function? So how important it is to a refrigeration system. Okay, so the rule of a compressor, of course, it's obvious, it's to get cooling, right? So the function of a compressor is to increase the pressure and corresponding saturation temperature sa iyang boiling point of the refrigerant vapor to high level so the refrigerant can condense by rejecting its heat through the condenser. Okay, so getting vapor compression cycle, nag-need na siya og 5 basic components to move heat from inside the refrigerator to the air in your house. So, una, natin gitawag na refrigerant. So, which is the working fluid that moves the heat around. Okay. Second, the evaporator. So, it is the heat exchanger on the inside of your refrigerator that receives cold liquid refrigerant. Okay, then the third, the compressor. The compressor that compresses that vapor to a much higher pressure. Then the fourth, we have the high temperature vapor, which is enters the condenser to a temperature at 10 Fahrenheit or 5 degrees Celsius higher than the ambient temperature of the room the refrigerator is in. And then lastly, this liquid passes through an expansion device, something that rapidly drops the pressure. So, ang panglima is liquid. Okay. So what will happen if refrigerators don't have a compressor? Okay, of course, refrigerator won't work without a compressor, right? So kung wala ang compressor, dili mag-work ang refrigerator or ang walay may tabong nga refrigeration system. No? So, compressor need gid na siya, diba natay tawag nga waan kaning condenser, compressor, evaporator, and expansion valve, diba? So, kung ang isa sa ila wala, missing, of course, dili mag-work ang refrigerator. So, that's all.
So after sa compressor wherein diri nga stage may tabo ang work, the high pressure vapor coming out from the compressor will enter the condenser. Herein the condenser is where the heat rejection process occur. So in this process, as the high pressure vapor refrigerant from the compressor moves out and enter to the condenser. So dire sulod sa condenser is composed of coil tubes wherein as the high pressure vapor refrigerant flows in the coil tube, the heat that is carried by the vapor will be released in the surrounding, which causes the high pressure vapor refrigerant to be converted into high pressure liquid refrigerant as it discharges from the condenser. So ang formula para makuha ang amount sa heat that is being rejected, simplify the enthalpy entering the condenser or denote as H2 minus the enthalpy leaving the condenser or H3, or the total heat rejected is equal to the mass flow rate multiplied by enthalpy entering the condenser minus the enthalpy leaving the condenser, or simplify heat rejected multiplied by mass flow rate entering the condenser.
So good day everyone. By the way, my name is James De La Peña. So today we're going to tackle about the coefficient of performance. So the coefficient performance is the ratio of the refrigerating effect to the work of compression. So the formula of the coefficient of performance is equal to it is equal to heat sa low ug heat sa high. Ang heat sa low is equal ay over to work sa compressor, which is the H1 minus H4 over H2 minus H1. Ang sa coefficient sa heat sa high is over work sa compressor is equal to H1 minus H3 over H2 minus H1. So the power of kilowatts of refrigeration is the inverse of the coefficient of performance. And efficient refrigeration system has a low value of power per kilowatts of refrigeration but high coefficient performance. So when the COP or coefficient of performance rises, it means that the cooling output rises in proportion to the power input. So when the COP increase, equities is greater yung efficiency. So when the
efficient or efficiency of
performance is
the
higher, the power
system or the refrigeration system. So
consumption is
efficiency is
higher,
the correct
and
sizing or
the
design
running costs are
bago
higher.
na to i-achieve sa system.
So that's
So we
all.
have
Thank you.
here a formula which is VD is equals to pi over n multiplied by the d squared times L times N. So where VD is the displacement rate of compressor, and D is the diameter of the cylinder, L is the length of stroke, N is the number of cylinders for single acting compressor, and also in the double acting compressor. So N represents as the compressor speed. And then a single acting compressor makes one complete cycle in one revolution, and in a double acting compressor makes two complete cycles in one revolution. So we have actual volumetric efficiency. N of VE is defined as NVE is equals to the V1 over VD, where V1 is the volume flow rate entering the compressor, or the mass flow rate times the specific velocity, specific volume. On VD is the displacement rate of compressor. So morning nasa morning siya na formula, makuha na to ang VD or the displacement rate. So the displacement rate is the volume swept through by the pistons in their suction strokes per unit of time. And then we have also the clearance volumetric efficiency, NVC, is given by NVC is equal to 1 plus C minus C times the pressure 1 over pressure 2 over pressure 1, or the pressure ratio raised to the power of 1 over K, or is equal also to 1 plus C minus C times the volume ratio, specific volume ratio of the refrigerant, or the, and then C is the percent clearance, then V2 or V1 is specific volume, V2 is specific volume of vapor after isentropic compression to pressure 2, same also with specific volume vapor 1 to the after the isentropic compression to P1, and where K is equals to 1.304. It's a constant for ammonia. Then we have also the adiabatic compression efficiency, or simply compression efficiency, NC, is defined as NC is equal to isentropic work, or H2 minus H1 over the actual work, which is equal also find power required over the mass flow rate. The mechanical efficiency in M is given by Nm is equals to W1 over WB. W1, or the indicated horsepower of the compressor, and WB is the brake horsepower of the compressor. Indicated horsepower of the compressor is equal to the mass flow rate times the actual work, while the BHP, or the brake horsepower of the compressor, is equal to the input sa motor times the motor efficiency. So that's it. That's are the efficiency of the system na kinahanglan nato also nga maghanapon. So that's all. Thank you.